Trying to get my stuff together here. Okay, we're over here, go to math.com, click on the algebra. Let's go down to equations. Now, this is a pretty useful section, believe it or not. There's some usefulness going on here. Solve for x. This little setup right here, especially when we're trying to convert, let's say, for example, let's say from the English system to the metric system, right? We're trying to convert inches to centimeters, or centimeters to inches, or inches to feet, or miles to centimeters. Okay, the way we've got it written right here is very useful, right, for doing such things. But we'll get to that here in a minute. Very useful. We have x over 7 is equal to 5 over 3. 5 over 3. Alright. So we have x over 7 is equal to 5 over 3. And we want to solve for x. Solve for x. Right. So what we're going to do here is just multiply both sides by 7. And as you can see, those will cancel out, and you'll have x is equal to, and of course, is there a number that goes into 3 and into 7? Well, 1's the only one. That doesn't do anything. So we can't really reduce this down any, so we'll just multiply 5 times 7, which is 35 over 3. And so there is your x. There's your x. 35 over 3. Alright. Now let me just go back here real quick, something I was talking about earlier. So for example, we know that 1 inch is 2.54 centimeters. And so let's say that if I had 10 centimeters, how many inches is that? You see this right here? This is x. X is the unknown quantity, and that is how many inches would that be. So if I have, we know this is a definition here, we know that 1 inch is equal to 2.54 centimeters, and if you had a 10 centimeter bar, how many inches is that? So you see, that's how useful this is, man. And now let me tell you, you can use it in a lot of cases. I did a treasure hunt just recently where this is, you were given the coordinates and this is where you started. You had to find the star, but X marks the spot as where the treasure was located. So once you found the star, okay, you could easily find X marks the spot. And on the treasure map, you knew this distance, and it was like 6 centimeters or something like that. No, let's see, wait a minute, 2, 4, 6, I don't know, something like that. And you could measure this distance on the map. We'll say that that's 8 centimeters. But in real life, in the real world, this was something like 1 kilometer, we'll say, right, since we're using metric. This is, so you had to actually measure the distance in the real world, not on the map. It was 1 kilometer, 1 kilometer. And so, right, so this would be like 1 kilometer over 6 centimeters is equal to, okay, so you knew this was 8 centimeters, but you didn't know what the distance was in the real world, and so that was your x. You see, so once you found this star right here, then you knew this guy right here, and these two were actually given. You'd had to get out a ruler and measure that, but then you would just solve for x. Of course, we had this angle also, which was like 100. This is not 106 degrees, I don't think, but it was like 106 degrees. So you had to measure that, but that was no big deal. But so this stuff is extremely useful, especially if you're trying to draw treasure maps. But it's a lot useful for a lot of things. Okay, so that's what I wanted to get on with that. And did we ever look up the answer on that? Yeah, we did. Alright, so we're over here at GoToMath.com. See you in the next problem. Okay. Okay, we're over here at GoToMath.com. Click on the algebra. Let's go down to equations. We are learning some useful math here. Solve for x. Okay, so we have 3 over x is equal to 6 over 3. And of course, if we can reduce this down, we probably will before we even get started. And I can see something here that can be reduced down. Alright. So we want to solve for x. Solve for x. So we have 3 over x is equal to 6 over 3. Now this will reduce down. You see that? And we have 3 over x is equal to, 3 goes into 6 2 times. Okay. Now we can consider a 1 being right here. Now what you could do is you could flip this around so that x is on top. Alright. And then we can multiply both sides by 3. Those 3's cancel out and we're left with 3 halves. Left with 3 halves. Right. Okay. Yeah. So 3 halves. And you can always test this by taking the 3 halves and plugging it in right here, and you should get well, 2 if we wanted to simplify that down. I want to simplify that down. Alright, 3 halves. Okay, so see you in the next problem. Well, wait a minute. We're over here at GoToMath.com. See you in the next problem. Okay, we're over here at GoToMath.com. Click on the algebra. Let's go down to equations, and we're doing 2.1. It looks like. Right. 9 times x over 2 is equal to 2/5. And we want to solve for x. Solve for x. Solve for x. Solve for x marks the spot. So we have 9x over 2 is equal to 2/5. Equal to 2/5. Okay. So the first, let me use a different color this time. We'll multiply both sides by 2. That'll get those to cancel out. And we'll be left with 9x is equal to 4/5. And then what we'll do is multiply both sides, I guess we'll just use blue, by 1/9. That'll get those to cancel out, and therefore will be equal, x will be equal to, let's see, 4 over 45. Okay, now there's not a number that'll go to end to any of these, so other than 1. Alright, x is equal to 4 over 45. Of course, I just state that part of the answer. 4 over 45. Got it. We got it. Alright, we're at GoToMath.com. See you in the next problem. Okay, we're over here at GoToMath.com. And we're looking at 2.2. Trying to get this thing written down. I'm having some issues. Something stuck to my pen. So we have 6 over 2x is equal to 6/5. And we want to solve for x, because x is overrated. Alright, so the best thing to do here is, what we could do is we could, well, look at here. We could actually simplify this down. 2 goes into 6 3 times. So there you go. Simplify it down to that. Alright. And you can flip this fraction over, since we need to solve for, whoops. Well, we're not solving for whoops, but 5 over 6. Okay. Yes, you can do that. See, what happens is if you took the x up here and the 3 down here, And then the 5 up here and the 6 down there, you just end up with the same thing. See, so just flip them. Okay, then we can multiply both sides by 3. I guess I won't change colors. And therefore x is equal to, now 3 goes into 6 2 times. So we have 5 over 2, 5 halves. 5 over 2, x is equal to 5 halves. Or I may just say 5 halves. Is the solution to this equation. See that? And you know what? I hadn't done this in a long time. I was kind of scared to actually. 5 halves, correct. Okay. Alright, so we're over here, go to math.com. See you next problem. Okay, we're at go to math.com. Click on the algebra. Let's go down to equations, and we're looking at 3.1. And things are starting to look a little bit more complicated. We have x plus 4 over 8. That's equal to 7 over 3. Alright, 7 over 3. Alright, so we want to solve for x. This equation. So we have x plus 4 over 8. And that's going to be equal to 7 over 3. Okay, so we want to multiply both sides by 8. And therefore those 8's will cancel out. We have x plus 4 is equal to, and 3 doesn't go into 8, so that's not going to simplify down any. 7 times 8 is 56 over 3. And now what we want to do is subtract 4 from both sides. Okay. And now what we got going on over here is we need to get, let's put a 1 down here, okay? We need to get this all into one single fraction. That means we need a common denominator, so we're just going to multiply the bottom by 3. But we got to multiply the top by 3, right? So we don't forget all that. So we've got 56 minus 12 over 3. 56 minus 12 over 3. What have we got on that? It's 56 minus 12 divided by 3. So okay, I guess not. So we end up with, it looks like 44 over 3. 44 over 3. So that's going to be a solution, the solution to this equation, 44 over 3. Right, so if you plugged in 44 over 3 over here, this whole side should end up reducing down to 7/3. Alright, 44 over 3. So there you go. Okay, so we're over here, go to math.com, solving some rational equations. See you in the next problem. We're over here, go to math.com, click on the algebra, let's go down to equations. We're looking at 3.2. That's what we're going to be looking at. So we got 2 over x plus 3 is equal to 2 over 7. 2 over 7. 2 over x plus 3 is equal to 2 over 7. And what are we doing here? I didn't write this in the last one, but we're going to solve for x. Solve for x. So remember what we can do to both these fractions. We can just flip them and put x plus 3 here, as long as we put 2 down below, and flip this side. You must be able to flip this side also. So remember, that's just like taking x plus 3 diagonally up here, 2 diagonally down here, 7 up here, 2 down there. You get the same thing. Okay, now what we can do is multiply both sides by 2 to get rid of this 2 here. So now we're left with x plus 3 is equal to, and look here, those cancel out, right? And then we just subtract 3 from both sides, and we get x is equal to 4. Right, now if you look at this, plug 4 in, 4 plus 3 is 7, and you'd get 2 7s, which that's what this is over here. Alright, see what we got here. 4. Alright, so we're getting it worked out. We're over here, go to math.com. See you in the next problem. Over here, go to math.com, click on the algebra. Got x plus 2 over x plus 15 equals 9 over 11. 9 over 11. All right. Okay. Before I fall asleep, we better get this problem done. Got x plus 2, x plus 15, I believe it is equal to 9 over 11. 9 over 11. Alright, well, this one's not exactly cut and dry, that's for sure. Let's do something here. We're going to multiply both sides by, I didn't actually give me enough room here, but we want to let's take this over to the other side of the equal sign, and we're going to be taking it up here diagonally. It's the same thing as multiplying both sides by x plus 15. Okay. So we have x plus 2 is equal to 9 times x plus 15, and that's all over 11. All right. Now let's take this 11 over to the other side. So this becomes 11 times x plus 2 is equal to 9 times x plus 15. Okay, I think we're getting somewhere now. We'll go ahead and distribute this 11 across. We have 11x plus 22 is equal to 9x plus, and 9 times 15 is, see, 90 and 45, 135. Yeah, 135. It sure was. 135. Okay. And now what we can do, you should have worked problems like this in an earlier section. Take this 22 over here, and we'll take the 9x over here so we can get our like terms together. So we have 11x minus 9x is equal to 135 minus 22, right? We're subtracting 22 from both sides and subtracting negative, or 9x from both sides. Okay, so what do we got here? We've got 2x is equal to 135 minus 22 is 113, and therefore x is going to be equal to 113 over 2. Right, because you're going to multiply both sides by 2, or half. Multiply both sides by half. Alright, 113 over 2. 113 over 2. Well, I think we're right on that. Okay, so we're over here at GoToMath.com. See you in the next problem. Okay, we're over here at GoToMath.com. Click on the algebra. Let's go down to equations. And we're going to be looking at 4.2. 4.2. Right. So we have 9 over 18 is equal to, and that'll reduce down, x plus 13 over x plus 2. Yep. But we'll go ahead and write out the whole thing here. 9 over 18 is equal to x plus 13 over x plus 2. So as you can see, this will reduce down, right? 9 goes into 18 2 times. 1/2 is equal to x plus 13 over x plus 2. So what we'll want to do is take this x plus 2, move it up diagonally up here in the top. So we'll have 1 times x plus 2. And let's move this 2 to the other side, and that'll be moved up to the top, right? Because what are we doing? We're multiplying both sides by 2 when we do that. So remember that. So we have x plus 2 is equal to, let's distribute that 2 across, 2x plus 26. Now we're going to want to take this x over to this side because it only has a coefficient of 1. Right? 2x minus x, and let's take this 26 over to the left, and so that'll be 2 minus 26. Okay, remember it's just the opposite of what this sign is right here when we move it to the other direction. Okay, so that's going to be 24 yeah, is equal to x, because 2x minus x is x. X is negative 24. Now you can always come up here and plug that in up here, and we should be getting 9 over 18 or 1 over 2. Right. And what was that number again? 24, yeah. 24. Just making sure. Alright. Okay, so we're over here, go to math.com. See over here. Okay, we're here, go to math.com. If you didn't know, probably already do. We're doing 5.1, if I can find it. Where's it at? There it is. 5.1. Alright, so we got 17 over x plus 18 is equal to 7 over x plus 7. So remember, we're solving for x. So we have 17 over x plus 18, and that's equal to 7 over x plus 7. Alright, we're solving for x. So what I'm going to do is take this x plus 7 over to the other side, and that means we'll be taking it to the top. And then the same thing here, this x plus 18. Take that to the top. Remember the reason why we're doing this. We're skipping some intermediate steps now. Right? And then multiply the 17 across. We got 17x plus, what was that, 1, 9, 4, 9, 7, 9, yeah, 17 times 7, 14, 19. I think my mental clock was working very good on that one. So 7x plus 70 and 56 is, ooh man, what is that? Alright, 126. And then of course we'll get the like terms together. We're going to take that 7x over here to this side. So this will become 17x minus 7x is equal to, and then we'll take that 119 over here. And remember, it's always the opposite sign. Alright, and so we have 10x is going to be equal to something, 7. Alright. And then of course, multiply both sides by 1 over 10. So x, you know what, let's write it over here. X shall be equal to, and we can't reduce that down any, 7/10. 7/10 is our solution. Let's hope anyway. Alright. So there it is. We're over here, go to math.com, get it worked out. See you in the next problem. Okay, we're over here, go to math.com, and we're looking at 5.2. Alright. And wouldn't you know it, I'd get the cursor in the way of that. Okay, so we got 6 over x plus 3 is equal to 5 over x plus 11. X plus 11. Right. So 6 over, this looks like the same kind of problem. What's going on here? What's the story? 5.2. I hate to have to click on that. I didn't already do 5.2, did I? Normally I don't have problems that are exactly alike. So that makes me wonder. I guess we'll just work it out and see what happens. I mean, usually there's some kind of change, a little variance of some kind. So let's take this x plus 11 up here to the top. And we're going to take this x plus 3 up also. Distribute that 6 plus 15. Right, so we want to take this 5x over to this side and the 66 over here. So we're going to have 6x minus 5x is equal to 15 minus 66, and so that becomes x is equal to a negative, what is that, 51, of course. All I do is reverse those digits there, huh? X is equal to negative 51. I'm kind of curious. Find this out here. Alright, let's take a look at what 5.1 looks like. Looks the same. Usually I try to change stuff up. I don't know what happened there. Alright, so we're over here at gotomath.com, figuring it out. See you in the next problem. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to rational equations. And we are looking at 6.1. Whoa, what's that? I'm gonna turn the page here, something to write on. Okay, so we have 140 over x squared plus 24 over x is equal to negative 1. Alright, I got that. I got it. 140 over x squared plus 24 over x is equal to negative 1. Alright. Wow, what do we do with that? Well, what we could do is multiply the top by x here and the bottom by x. We get a common denominator. So we're going to have 140 plus 24x over x squared. See, we'll get a common denominator here, and then we can just add both these fractions together. Is equal to negative 1. Equal to negative 1. Now what I can do is multiply both sides by x squared, and that'll get rid of that. So now we're left with 140 plus 24x is equal to negative x squared. Right, negative 1 times x squared is just negative x squared. Now what we can do is bring that x squared over to this side. That'll make it a positive, plus, we'll write this in a standard form, and then plus 140 is equal to 0. Now, you've done some of these in an earlier section. I think we were factoring the quadratics, the quadratic equation. So that's what we're going to want to do here. Okay, I'm sure this thing will factor nicely, even though we got to deal with 140. Okay, so we know it's going to be two positive numbers. Remember how to do this. A times b is equal to 140, and then when we add them, we're going to get 24. Alright, and so we're going to need to start breaking 140 down, it looks like. We add them, we get 24, so we need to break that in the middle as much as we possibly can. Let's see, we know that 140, 70, is that right? Yeah, well, that's not going to give me 24. Let's break this down. Let's do, we know that 2 and 70 will give us 2 times 70 gives us 140, but there's no way we can get 24 here. Okay, so let's break 70 down. We know that 35 goes into 70, right? 35 goes into 70 2 times. So we could say 2, 2, and 35. Alright, we know that. had to be 4 and 35, but that's not going to give us 24. Okay, well, let's break it down some more. We got 5 times 7. Right, 2 times 2 times 5 times 7 should give us 140. 5 times 7 is 35. Alright, let's look at 2 times 2 is 4. And, 4 times, oh, no, that's 27. Man, what is going on here? I've already spent way too much time on this problem. 2 times 2 is 4. 24. That's 20, but that would be 7. Did I mess something up here? What's going on here? Oh my god. 140x squared, 24, negative 1. Okay. Alright. What are some other possibilities? We got, let's see. Ooh, wait a minute. 14 and 10. There we go. 2 and that. Okay, that's going to be 14 and 10. Yeah, 14 and 10. So x plus 14 and x, there's just too many possibilities in this problem. X plus 14, x plus 10, because, right, 10 times 14 is 140, and I should have already gotten this. I don't have to, now you look at it. And then you add these together, you get 24. Okay. So you would set both of these equal to 0, and we did this earlier, so this shouldn't be a big surprise. So this one's going to be negative 14 and negative 10. These are going to be the solutions to this equation up here. Negative 14 and negative 10. Okay. There they are. Alright. And I think the smaller number, if you're plugging it in up here, is always going to be on the left, and then the larger number. Alright. So we're over here at GoToMath.com trying to get it worked out. See you in the next problem. Okay, we're over here at GoToMath.com. Click on the algebra. Let's go down to equations. We're doing 6.2. If I can get it to come up. Alright. So we have 12 over x is equal to 1 plus 32 over x squared. 32 over x squared. Alright. Now, we can do this way. There's ways of doing stuff. To get rid of these denominators, we can multiply through all the way across by x squared. Let me just show you how to do that. So we multiply that by x squared. So if we can write that in there. That by x squared, and we'll multiply it on this side. It's okay. And that side by x squared. Now what's going to happen here is these x squareds will cancel out. And we have 1 down here, 2 up here, so we'll be able to cancel one of those out, and we'll just be left with an x to the first power. So let me rewrite now. So we're going to end up, and I'm going to put that 12 on this side. So we're going to end up with a 12x is equal to x squared. 1 times x squared is x squared. And then those canceled out, and we're left with 32. Now let's get this in standard form. So I'm going to go ahead and take this, since this is a positive coefficient. Let's take the 12x over to the other side. So we have x squared minus 12x minus 32. Alright? And now, of course, what we're going to do is factor this thing. Hope it factors. Sure, it probably does. Alright, so we'll want to factor. Now, 32 is the number we're looking at, and let's look at some numbers that go into 32. We've got, let's see, 8 and 4, right? 2 and 16. I'm going to write 2 and 16 here. Now, let me just go ahead and do this. A times B is equal to negative 32. And then A plus B will be equal to negative 12. Alright, so only one of these are going to be negative. Either A is negative, B is negative. Right, one of them will be negative and the other one will be positive. So that's something we got to keep in mind. Now let's take a look at this here. If 16 were negative and 2 were positive, we would get 14, not negative 12. Make sure I wrote that down right. Yeah. Okay. Well, shoot. I was hoping that was going to be the answer, but it's not. Right? 16. That'd be 14. Crud. Okay. Let's see. Let's look at. We know we can break this down some more. 2 and 8. So 4 and 8. 4 and 8. I think that's what it is. 4 and 8. Right, and that'll be a negative 8. Yeah, because that'll make, let's see, 4 times negative 8 gives us negative 32. And if that's 4, B is negative 8. That'll give us, that doesn't give us negative 12. What am I thinking? I'm not. What the heck? I thought I was on a roll there for a minute. That's going to give us a negative 4. We need a negative 12. Okay. I was really thinking that was it. Alright, that's okay. Hang in there. Okay, we can actually break down something. We can break 8 down again. Right, let's write this 32 down again over here. So, let's see. 4 and 8. Okay, 4, 2, and 4. That's still 8 and 4. 16 and 2. We already looked at that. Okay. Something I'm not seeing here. Alright, let me factor this completely. 2 and 16, but 16 can be broken down to 4 and 4, but that could be broken down into 2 and 2, 2 and 2, and another 2. Yeah, 2 to the 5th. So we looked at 4 and 8, and only one of them could be negative, right? In order for that to be a negative, yeah. Okay, 2 and 16, okay, we looked at that. That's not going to work. 4 and 8, 4 and 8. No, 4 and 8 can't work. 4 and 8, and then that would be 2, 4, 6. Oh, 6 and 4. How did I miss that? No, that can't work either. Wait a minute, 6 and 4. 2 times 2 is 4. Oh, that's 8 and 4. What is going on? Man, I don't see this working. Oh, I'm getting tired. What is going on with this problem? Something is fishy in St. Louis. And I see what the problem is. Apologize for that. My God. I don't know why I put a negative there. And everybody else is probably like, you dumbass. I shouldn't say that. Okay, so we got 2 negative numbers. And that goes back to 4 and 8, obviously. Wow. That's what I'm talking about. So 4 and 8 are the 2 solutions, right? That gives me positive 32 and a negative 12. Okay. Yep, I'm not going to redo this video. It ain't happening. Alright, just goes to show you people who've been doing math for a long time can still make mistakes. We're over here at gotomath.com. Getting a headache. I'm going to take an aspirin. See you in the next problem, maybe. Bye. Okay, we're here at gotomath.com. Click on the algebra. Let's go down to equations. Okay, we're going to be doing 7.1 here. Alright, so let's write that down. We got 154 plus 25 over x. Let's see, plus 1 over x squared is equal to 0. If you didn't get it down, I've already got it written down for you. Okay, so we want to get this thing all in. Want to get rid of these x's down here in the bottom is what we really want to do. We're trying to solve for x in this problem. And the best way to do that is multiply through by x squared all the way across. So in other words, this is x, multiply that by x squared, x squared, x squared, but we have to do this side also. Okay, and x squared. Okay, now I'm going to rewrite this. This is 154 x squared plus, now of course there's an x down here in the denominator, so that's going to cancel one of those x's out. So we'll have 25x, and then plus 1 is equal to 0. Is equal to 0 here. Okay. And this is not very nice looking, to say the least. Did I write that down right? Okay. So we need two numbers that when multiplied together that's going to give us a 1, right? So, right, a times b is equal to 1. Well, obviously it's got to be 1. But then when we add some numbers together, we're going to end up getting 25. But then we got this joker over here to deal with. And 10 and 15. Let's see. I'm going to go out on the line on this one. We know that's got to probably be a 1. 11 goes into 154, doesn't it? Sorry, I got to cheat on this one. 154 divided by 11 is 14. 11 and 14 is 25. No. 11 and 14. Yeah, it's 25. Oh my God. 1 times 1 is 1. 11 times 1 plus 1 times 14 gives me 25. Of course, that's equal to 0. Alright. Erase that over there. Okay, so then what we're going to do is set both these factors equal to 0. It's not exactly an easy one here, I will admit. So we end up getting, taking the 1 over negative 1 over 11, and then we set this factor equal to 0. Solve for x, and we get x is equal to negative 1 over 14. Negative 1 over 11, negative 1 over 14. Man, I had to go negative 1 over 11, negative 1 over 14. Yeah. Alright, so there we go. Ooh, that was a hairy one there. Okay, so we're over here at GoToMath.com getting it worked out. See you in the next problem. Okay, we're over at GoToMath.com. Click on the algebra. Let's go down to equations. We're looking at 7.2. 7.2. Okay. So we have 12 plus 1 over x squared is equal to 7 over x. Okay, so let's get rid of this x squared down here. And we're going to do that by multiplying all the way across. I'm going to use a different color here so you can see what's going on. So we're going to multiply x squared. And the reason we're multiplying x squared all the way across is to get rid of this x down here, and it'll get rid of this one here also. Okay. So I'm going to write that 12 out front here. So we have 12x squared plus, and of course those are going to cancel out. You're just left with a 1. And then of course there's 1 down here, 2 up here, so this will cancel out and you'll be left with just 1 in the top. 7x. But we want to get this in a standard form now. So we have 12x squared. Taking this 7x over to the other side of the equal sign, we'll be changing the sign. Minus 7x, then plus 1 is equal to 0. Okay? Alright, so once again, we got a negative right here though, this time. Doing the same thing. Taking a look at 12, first off, that's a 1, so we know that, we'll leave some room here. This is going to be a 1. Of course, this could be a fraction. Times a fraction, you could get 1. But we're not doing that, so don't worry about that. So we know there's got to be a 1 here. Now, because this is a minus sign right here, chances are these are both going to, well, these are both positive. Okay? I mean, they could be negative, actually, and make that positive, but I don't think you got to worry about that. But one of these, I think both of these actually are going to have to be negative. Okay? Negative 1 times negative 1 is a positive 1. But now we got to look at 12 and 7. So 3 and 4, let's put 3 here and 4 here, because we know that 3 and 4 gives us 7. Right? So 3 times negative 1 is negative 3, and then negative 1 times 4, that's going to be a total of negative 7. And then of course you've got negative 1 times negative 1 gives us a positive 1. So that looks like that's going to be it. So now what we want to do is set both these factors equal to 0 and solve for x. So we're going to end up with x is equal to 1 over 3. And then we'll do this one here. Set that equal to 0. X is equal to 1 over 4. So this far in the game here, you should know how to solve for x for these two linear terms. Okay? So we have 1/3 and 1/4. 1/3 and 1/4. Okay? Now, here's a little pattern here. You notice that 1/4 is smaller than 1/3. Well, the smaller number, since these are positive, and if you're looking at it on a number line, okay, the smaller one is going to be on your left and the larger on your right. Whereas this, if these were two negative numbers, right, this would be the smaller, and that would, well, no, wait a minute. The most negative, that'd be kind of the bigger number. The bigger negative number, the smaller negative number. Anyway, well, actually, they'd be flipped around on this particular case. Alright. What are we doing? Oh, we're done. Okay, we're done with that. We'll see you in the next problem. Okay, we're going to GoToMath.com. Click on the algebra. Let's go down to equations. And we're looking at 8.1. Holy crud, what is that? Ooh. Alright, I'll have to write this one down. 5x squared plus 63x plus 100. And that's all over 5x plus 8. And that's equal to 12 over 5x plus 8. Okay, got that. So we have 5x squared plus 63x plus 100, and that's going to be all over 5x plus 8. Set that equal to 12 over 5x plus 8. Okay, so we want to solve for x, and that means, well, we need to get rid of this stuff down here in the denominator. Okay, and we can simply do that by just multiplying both sides by 5x plus 8. Yeah, why can't we just do that? Right, multiply this side by 5x plus 8 and 5x plus 8. So that means that'll get these guys to cancel out. Yeah, that's legal. You can do that. Why not? Let's see, why not? Okay, so then we're left with 5x squared plus 63x plus 100 is equal to 12. Now we'll want to get this in the standard form, so we're going to take this 12 over here to this side, and when we do that we have to change the sign. It's the same thing as saying, look, subtract 12 from both sides, right? To get 0 over here, same thing. So we end up with 5x squared plus 63x, and then of course 12 minus, or 100 minus 12 is 88. 88. And this is looks pretty nasty actually. Okay, so we're going to want to factor this now because we have a 5 here, and that can't be factored other than 1 and 5 itself goes into that. In other words, 5 is a prime number. Then it's got to be starting with a 5x, and then this would have to be an x here. Okay, and both these are plus, so that's good. So that means this is going to be a plus and a plus. Now we're looking for two numbers that when multiplied together gives us 88. Right, and so things of 88 are things like 1 and 88. And of course 2 goes into 88. That's going to be 44. Now let's look at this number here, 63. What else? How else can we break this down? This is 11 and 4. So let's see, 11 and 4. We know that 8 and 11, right, is 88. Let's see, 44. Let me write over here. Let's see, we had 2, 11, and 4, right? 44, 88. That breaks that down to 2. Let's see, 22 and 4. Is that another one? 22 and 4. Okay, well, we know that we have to have two numbers multiplied together. It's going to give us 88. And we've also got this number here. So if this were an A and this were the B right here, okay, right, so A times B is 88. But we're going to need to do 5 times B, 5 times B plus A is going to be equal to 63. So this might help us out here. Right, so let's run through some of these numbers here. Let's see, that's 40. If I put an 8, if B is 8, that would be 40. And then 11 is 51. That's not going to get us 63. Okay. Now, if I were to put the 11 here, that would be 55. And 55 and 8, wait a minute, I think that's it. 55 and 8 is 63. Okay, so if this were a 11 and A, there we go. I think I just found it, didn't I? That's 55 plus the 63 plus 11, or 11 times 8 is 88. Okay, so this is kind of a way of doing this to help organize your thoughts. What do we say? B was 11 and A is 8. Okay. Alright, so if you set both these factors, I better put an equal sign here. If you set both these factors now equal to 0 and solve for x, we should be done. So x is equal to negative 8 over 5, and then x plus 11 equals 0, so x is equal to negative 11. Alright, that should be it. Man, that was a hairy one there. Hairy, scary. What did we say again? Negative 11 and negative 8/5. Ooh, negative 8 over 5. Bloop. That gives us 0. Okay, I see something on the negative 8/5 here, which would end up getting us 0 here, and that wouldn't actually be a solution, so I forgot about that. If you put in the negative 8 over 5 right here, we'd end up getting 0 in the denominator, okay, and you can't divide by 0. So that's really not a solution to the equation, okay. So the only solution to the equation is going to be your negative 11. Alright, so that's kind of a trick here, and that's something we gotta watch for. Alright, so we've got two solutions. Because this says 2 right here, this tells us that we're going to have two solutions, and they may not be real. We hadn't got to that section yet, but these are two real solutions. However, this one here we can't use, okay, and that is because when you put it in the denominator right here, we end up getting, like if we put it in right here, negative 8 over 5. Yeah, negative 8 over 5. The 5's cancel out, you get negative 8 plus 8, and that's 0, and you can't divide by 0, you see, so that's the reason that's not a solution. Okay. Alright, glad I caught that. Okay, we're over here at GoToMath.com. I'm going to work it out, see you in the next problem. Okay, we're at GoToMath.com. Click on the algebra, just go down to equations, and we need to click on, what do we need to do here? We need to be clicking on 8.2. Okay. Alright, so we have, what do we got going on here? We got 14x squared plus 41x plus 39 over x plus 2x. Alright, writing this down here real quick. Okay. Alright, let's move over to the whiteboard. So we have 14x squared plus 41 x plus 39, and that's going to be whoops, we got something down here below, x plus 2, and that's equal to 13 over x plus 2. Okay, so in the previous problem we had a solution that when we plugged in the denominator we ended up getting 0. My guess is probably the same thing's going to happen here. So we need to look for probably a negative 2 here as one of the solutions. That kind of helps us out, doesn't it? I mean, yeah. So if we were to multiply both sides by x plus 2, if I can squeeze that in over here, and x plus 2, right, what's going to happen is these are going to cancel out, and now we're going to be left with 14x squared plus 41x plus 39 is equal to 13. So we'll subtract 13 from both sides, and we'll end up with 14x squared plus 41x plus 39 minus 13, and that'll equal 0. So just think about it, taking this to the other side, and the sign changes. Instead of plus, it becomes negative. Okay, fast way of thinking about that. So we have 39 minus 13 is 26. Is that right? Or 39. Yeah, that's 26. I was thinking, okay. Alright, so let's rewrite this again. So we have 14x squared plus 41x plus 26 is equal to 0. Alright. Okay, so we want to factor this, and we're looking at 14, we're looking at 26, and I'm going to go out on the line here. This number could be 1, a 14, a 2, or a 7, but let's say it's 14. That's going to be my guess on that, and therefore that would have to be an x, and since both these are plus, we know that this will be a plus, and that'll be a plus there. Alright, now this guy here, well, you just never know on this. It's going to be 1 or 26. It could be a 2 and a 13. I'm going to look at 2 and 13 here. If I put a 2 here at 13, 14 times 13 is obviously going to be bigger than 41. Let's see, what about 13 and 2? Let's see, 2 times 14 is 28, and 28 and 13. I'm trying to do that in my head. Is that 41? I think it is, 28 and 13. I think we might have got lucky on this deal, because there are some other... Well, no, wait a minute. We can't break that down anymore, can we? What the heck am I thinking? It's 28 and 13. I think we got it. Well, it's always a shot in the dark on doing this stuff. Alright, so we got 14x plus 13. Set that equal to 0. And we get x is equal to negative 13 over 14, right? One of the solutions, and then of course x plus 2, and I just now remembered that that was going to be one that we're not going to be able to use, negative 2. So this looks like this is going to be our only solution. Remember, we can't use negative 2 because when you plug negative 2 down here in the denominator, we get 0. Can't divide by 0. Okay. Alright. And negative 13 over 14. Yep. Alright, that wasn't too bad. Okay, we're over here, gotomath.com, finding the solutions, and I'll see you in the next problem. Okay, we're at gotomath.com. Click on the algebra to go down to equations. We're looking at 9.1. If I get that to come up, there it is. 9.1. So we are working our way right down the list. I'll be glad when I finish algebra, so I can move on to bigger and better things. Alright, I got that written down. I think probably moving on to trigonometry will be the next course that we'll be working on. That's a fun course because you can draw a lot of pictures with what you do in trigonometry. Associate a picture to the problem. Okay, so here we go. Let's get that x plus 8 out of the denominator here, and we're going to do that by multiplying both sides by x plus 8. Now, you know what? I hate to have to do this, but we're going to actually give some room here. What was over here? I've already forgotten. There it is. Okay, so we're going to multiply x plus 8 to both sides, and x plus 8 over here. I didn't want to put x plus 8 over here because it's negative up front. Now we can cancel these guys out, and so now we're going to be left with the negative 15 is equal to x times x plus 8. Alright, see that? Now let's distribute this x across. We get x squared plus 8x, and let's go ahead and take this negative 15 over to the right. That'll make that a positive 15. That's the same thing as adding 15 to both sides, right? Alright, so there you go. So now what we need to do is factor this, and that shouldn't be too difficult, considering we got a 1 out here. So what do we got? 15, 3 and 5. 3 and 5, and where that's going to be a plus and a plus, right? 3 times 5 is 15, and when we add them we get 8. Alright, so now what we'll do is set both these factors equal to 0. X is negative 3. Work on the other one here. X is negative 5. So one of these two solutions we're not going to be able to use probably. Wait a minute. Maybe we'll use them both. It's kind of odd. Well, negative 3. I did do this right. I didn't write anything down wrong. Right. 8x. See, x squared 8x. 15. 3 times 5 is 15. When we add them, we get 8. Yeah, that's got to be our two possible solutions. Now you can always go in and check your work by plugging these into, let's see, negative 3 and 8 is 5. 5 goes into, it's 3 times negative 3. Negative 3. Negative 3 is equal to negative 3. Okay. I guess we're not trying to be tricky like the last problem. Negative 5, negative 3. That's what it shows. Yep. Okay. So we're over here, go-to-math.com, get it worked out. See you next problem. Okay, we're at go-to-math.com. Click on the algebra. Let's go down to equations. We're looking at 9.2. 9.2. So we have negative 35 over x minus 12 is equal to x. Did we not just do this problem? Oh, there's a minus down here instead of a plus. Okay. Let's see how that changes things. So 12 is equal to x. Alright, and once again, not thinking ahead. Let's move that over. So we want to do something with this x minus 12, and that is, we got to get rid of that. And to do that, we can just multiply both sides by x minus 12. And that means that these now can cancel out. And so now we'll be left with negative 35 is equal to x times x minus 12. Okay, so let's go ahead and distribute this x across. We have x squared minus 12x, and then taking that 35 over here. Right. Okay, now we can factor. This shouldn't be too difficult to factor this one, since there's a 1 as a coefficient, and the 7 and 5. 7 and 5, my guess we're going to have 7 and 5 right here. 7 and 5 is 12. However, this is going to have to be a minus and a minus, okay? Negative 7 times negative 5 is positive 35, but negative, did I say negative 7 times negative 5 is positive 35? Negative 7 minus 5 is negative 12. Alright, let's now set both these factors equal to 0, so we're going to have x is equal to 7. And x is equal to 5. Okay, so 7 and 5, right, this is what you got to look for here, right? If one of our solutions was 12, we couldn't use it because then we'd be dividing by 0, right? But we could actually use both of these. Okay, like in those problems in 8.1 and 8.2, that's what you got to watch out for. That's tricky. Tricky stuff. Teacher take half point off for that probably. What do we got? Oh, let's get back to where we are. 5 and 7. Yep, 5 and 7. There it is. Alright. So over here, go to math.com. 2 more problems for this section, and we are done. I'll see you in the next problem. Okay, we're over here. Go to math.com. Click on the algebra. Let's go down to equations, and we're looking at 10.1. 10.1. We're almost done with this section. So we have x is equal to 27 over x plus 6. Well, that looks like a pretty easy problem. For me anyway. It looks like it, but looks could be deceiving, right? X is equal to 27 over x plus 6. So what we'll want to do is multiply both sides by x plus 6. So those will cancel out. X plus 6. There we go. And of course we'll be able to cancel them out now. So we have x plus 6 times x is equal to 27. Let's go ahead and distribute that x across. We have x squared plus 6x is equal to 27. X squared plus 6x minus 27 is equal to 0. Alright. So we can now factor this thing. So we know we're going to have an x and an x. 27. 9 and 3. Now you notice that's a negative. So one of these is going to have to be negative. Let's put a 9 here. And let's make that minus plus 3. Negative 9. Oh, that's not going to work. What was I thinking? I wasn't. What about that? Because 9 plus minus 3 is 6. And 9 times negative 3 is negative 27. Alright, let's just go ahead and continue this right up here. So we got x plus 9. Set that equal to 0. X is equal to negative 9 after solving for x in this problem. And then our other one is x minus 3. X is equal to 3. So here's our two possible solutions. We need to check that up here. Yes, we can plug negative 9 in and 3. Right, what we got to watch out for is getting 0 now, the bottom and the denominator of one of our fractions. So 3 and negative 9 looks like negative 9 and 3 is our solutions. Okay. Right, and of course, look at here. We can always check that now, remember, by plugging 3, for example, in. If I put 3 plus 6 is 9. 9 goes into 27 3 times. So this would be 3. And that's what we used, x is 3. See that? Or you can plug negative 9 in. And so this would be negative 9 over here. Negative 9, that would be negative 3. And then negative 3 goes into 27. Simplify that down, negative 9. Alright. Okay, you can always check your work there. So we're over here, go to math.com. One more problem and we're done with this section. See you there. Okay, we're going to go to math.com. Click on the algebra. Let's go down to equations, and it looks like this is the last problem. And are you kidding me? We had an easy problem in the last one, and now we're look at this. Oh my gosh. What is that? Is that supposed to even be in this section? I don't know. So we got x cubed over x squared plus 7x plus 49, and that's minus 343. Man, some smaller numbers. 7x plus 49, that's equal to 10. All right. Well, good news is we got common denominator, thank goodness. I think this problem could be a whole lot worse. Well, let's go ahead and rewrite the problem. plus 7x plus 49 minus 343 over x squared plus 7x plus 49. Set that equal to 10. Equal to 10. Well, because we have a common denominator, we can add both these together and we'd end up getting x cubed minus. Now I got a feeling this is a cubed number, and that means that to find that out we can take the cube root of it, 343, and see what we get here. 343 raised to the 1/3. Have we talked about exponents yet? 7. So it turns out that 7 cubed, and I'm going to write that up here, 7 cubed is 343. Okay. Now you should know how to factor this. I think we've gone over that several times in some earlier sections, so I guess it's quiz time. Alright, so there we go. We got a 10 here, right? We got a 10. Of course we got a 10. What am I thinking? What I'm going to do here is I'm going to go ahead and factor this up here. So this becomes x minus 7. So you got to remember how to factor the difference of two cubes, and then we're going to write 7x. Now it's a plus sign here because this is a minus, right? We write the opposite sign. 7x, and then we square this number, 49. See that? Now you see why I'm doing this. Because x squared plus 7x plus 49 is down here in the denominator, and you notice that these guys will cancel out, and we need to just go ahead and do that. See that? They'll cancel out. And yeah, you could have brought this over here to this side. I think this problem will get nasty then, and forget it. So yeah, those cancel out. So now we're left with x minus 7 is equal to 10. So this problem didn't turn out that bad after all. 10 plus 7, and let's write it over here. X is equal to 17, and that's going to be our only solution. X is equal to 17. Isn't that interesting? Huh. X is equal to 17. Yeah. And there it is. X is equal to 17. What do you know? Alright. Okay, so we're over here, GoToMath.com. We just finished up in this section. And what are we doing next? I guess you're going to move over to rational exponents. Let's just click on that, see what we got. Oh, okay. Got it. Alright, so that's what we're doing next. Okay, and I'll see you in that section, moving right along.